Good morning, sir.
Hello, good morning. Okay, good morning, everyone. So let's start. So when yesterday, we discussed about machine learning algorithms, right? And also we discussed what is the type of algorithm in terms of categories, right? We have supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning, and also the deep learning. Okay, so these are all the important algorithms when it comes to the machine learning, right? And also uh, we also discussed when exactly we have to use in terms of data. So if we have a labeled data, that is structured data in the the proper column, and if it is like properly labeled everything, then we can able to directly use the supervisory learning algorithm, right? If we don't have any labeled data, then in that case we have to use the supervised learning algorithms. Okay, and if we have a mixed labeled data as well as unlabeled data in single data structure, then we can use the semi supervised learnings. And fourth one is like if we don't have any fixed data set, right? In that case, the best algorithm would be a reinforced learning. Okay, and if you have very vast data sets, very the huge data set, it could be an image, PDF, or video, where it is a mix of structured and semi-structured as well as unstructured data sets, which usually will be stored in the blob storages like Azure blob storages, or else like S3 buckets, right? We can able to use this vast data sets by using the data deep learning. Okay, it uses the neural network for the data cleaning and data analyzing. Okay, when it comes to the machine learning modeling. So today we'll go into the actual models. Okay, so let me okay. So before we dive deep into the models, right? The individual models, ML models. So let's understand what are the models we will be studying. Okay, and so basically, yeah. Yeah. So before we dive into the individual models, right? So what we'll learn now is, so we'll understand what are the models, ML models, we can able to utilize in terms of energy management and the IoT systems, right? And then we'll see which model suits in which scenario. Okay. And so basically, I have divided these models into three categories. First, in the first category, so it is all about ML model for energy systems. Okay. So in this first section, we will talk about which are the models which are suitable for the energy management system or energy systems. Okay. In that, majorly we will discuss three important ML models. and there are a lot of machine learning models available. So you can choose any models and you can able to train it. But here I fed it two or three ML models, which will be helpful in our use cases, right? In that scenario, for that scenario, what I have done is I have selected 3 machine learning models. And coming to the second one, so second category, that is ML models for IoT applications or downloads. So the second category is for especially for the IoT applications, where we will be collecting the streaming data from the IoT devices, right? For that use case, I have selected the ML models. Okay, and the third category is for ML models for analytics. So this analytics is very much critical, because if you choose any of the data set or any of the field, it is not only related to the IoT or its energy management system, right? If you are considering any of the field, the analytics plays a critical role here, right, in any of the systems. So for that reason, we'll start with the analytics part. Okay, in the analytics also, I have chosen the 3, the ML models, where it could fit the analytics what we are going to do. So let's start with the analytics, okay, and then we'll move to the energy systems, and then IoT one, right? Now, as I said before, before we keep diving into the models, let's understand why exactly we have to choose the models and when we have to choose the models. Okay? And also we'll see the Python coding for these models. And also there will be a few assignments based on these models, and you can able to select your own models. That should be okay. And but yes, like there should be the model which needs to be developed during your assignment submissions. Right, so it should be a very much small, not the bigger one. Basically, you need to understand the concept, what exactly the model and how it works, right? And yesterday we spoke about what is the life cycle about the modeling, right? First, we have to ingest the data, then train the model, then the fine-tune the model, then try to use that model for the prediction, and then deploy it, right? That is the use cases. Now, coming to the comparison of this. Coming to the comparison of the model, so here we'll be taking in the 3 steps, okay, in the selection. The first step, we have to filter the problem type, okay. Why? Because, so if you see here, we have a lot of ML models available, right? Think like these are all the different model type, yeah. These are all the square two. Like this is just an example. So there will be a lot of ML models which are available. Okay. So, but if you see the problem here, the problems needs different solution. Okay. Not the single ML model can able to fit all the use cases what we'll be trying to solve. Correct. For that reason, we have to define the problem statement first. So, and we have to before we selecting any of the specific model, we have to say what exactly we are trying to predict here. Okay, is it the continuous data, or is it an static data, or what exactly is it the data in terms of the IoT devices? What kind of data structure? Is it an JSON format? Is it an perpetual format? The columnar format? So this kind of information gathering is very much required in the step 1. Right. After that, in the step 2, the data type. So I was mentioning about JSON format, right? So we have to check what kind of data. So yesterday I was mentioning about the data sets, right? So usually when we are considering the IoT, usually it will be a JSON format. So JSON format is a key pair value. Okay, when I say key pair value, so how the JSON format will be? It will be like this. So IoT device ID will be, let's say it is 100 or something. Okay, this is the key, and this is the pair. Okay, and similarly for this voltage, equals to some 230. Just for an example. Okay. Similarly, if we are sending in status of the device, is it an on, off, something like that. So this is how the JSON data will be. Okay, this is one of the format, right? And the second, the famous format is the CSV file. Okay, and the CSV file is a comma separated file. Okay, and we have the tab separated files. How this works is like, so all the data, it will be in the series. For example, the device ID and the status and the current value and voltage. So it will be in the same, but it will be separated by using the columnar. But the problem when we are trying to analyze this, right? So for example, this is the data set for us, right? The IoT data set. When we are trying to put this into the ML model, so ML model have to check all the data from the start to end. Okay? The time consumption is very much high. Very much high. Why? Because we cannot able to pick certain columns here, because this is not a columnar data. It is highly based on the row based data sets, correct? So we cannot able to segregate, or we cannot able to choose specific data set in this formats, JSON format or like a CSV format or TSV format. So this is one of the biggest problem when we are doing some the data analytics, right? So how do we solve this problem? So this is one why I'm mentioning these are like we need to know what kind of data sets we are generating or we are collecting, right? That is one. Now, so and the second, the problem we got to know that in the columnar, in the row wise data, that is CSV file and the TSV file, right? The model, ML model needs to scan complete data. Now there is other format called OCR format and the pathway format. So these are all the columnar formats, right? So basically these are all the open source Apache formats, and how the data will be stored is in the columnar format. Okay, let's say this is an IoT device, and this is the other parameters like say voltage, the current, the status of the IoT device, and let's say the manufacturing of that IoT device, the row 1, row 2, row 3, and the row 4, right? So this is how the data will be stored in the columnar format. Now, how this helps us in the modeling, machine learning modeling is, so ML model, it doesn't need to scan complete data, correct? So this is predefined schema, what we call as, where we already defined the proper table formats. right? The column and the row. So the machine learning model, if we wants to search only for the status, IoT status, then it can just simply check for the this specific column, and it don't have to scan the other columns, right? So if you go here and it will only check this specific, status column, then it will just check for the
Okay, sorry for this, guys. Like I had little technical problem. The system was disconnecting. Okay, I will jump back. So, yeah, somebody is joining the call. Okay, great. Mm, just a minute. My recording software is troubling me a lot. Okay, yeah, let's continue. Okay, so I was mentioning about the format type, correct? In the step number 2, we are we were talking about this data type, right? Yeah. So whenever you are and designing any ML system, right? So you need to be very much careful. You have to be sure that what kind of the data it is, right? Yeah. So in the columnar format, that is ORC or bucket, right? So we'll be having the columns. Okay. And in the columns, so we'll be having this. IoT data and other parameters, the voltage, the current, and the status of the IoT devices. Okay. So yes, I was talking about columnar data sets, right? So yes, so we have to make sure that we have the proper the format of the data. So usually we always prefer the columnar because the scanning of the data will be easier and the time consumption and the resource required for the scanning of the data is very much lesser when it comes to the columnar instead of row wise, right? That is one thing. Now, coming to the step 3, the filter 3, the constraints. So we need to know how fast must the my ML model needs to run. Okay. So is it like the time series? Is it and like the time is very much lesser and we need to select a model which needs to response very much faster. That is one thing. Or else, is it and the data set which is the static one and we have the time for the model to generate. Okay. So that is one thing. So, right. So, okay. Then that is how we have to choose the models. Now, whenever if we are asking any the questions in the examination, right? So define these steps in the selection of the ML model. You have to you have to define these steps in the selection of the ML model. So Okay, sorry again for this. So not a great day. The system is not supporting. It is getting, restarted because of some issues. I don't know what. Okay. So let's continue. Fine. Okay. Yeah, this is all about the three-step selection funnel. Okay. And if you see closely, so just think like this, like we have the different kind of ML models, right? And we have a different, the problem type. Okay. So that is one thing. Like we first in the first step, we have to identify the problem, and second set, we have to check what kind of data we are having, because like not all the data can be fit into the our machine learning model, right? And we have to clean the data to fit into the machine learning for the proper efficiency. Second one, the constraints. We have to think about the constraint, how fast the machine learning it should run. And then after doing this, the preliminary test and this one, like we will get the okay. So let's move further. We will not waste much time. And so now let's deep dive into the step number 5, right? The defining the problem statement. So here, like, so first one, the first model what we are having is regression, right? So in the regression, we have the three type of ML model, that is LSTM, that is very much a famous one, that is so long short-term memory one, and the second one is XGBoost and the Profit. Okay, so these are all the models which will fit the regression. Okay, so when we have to predict some series, the time series one, and then we have to do continuous analysis of any of the given model, right? So these are the three important ML models which will be selected uh, in the first place. Okay. And yes, so whenever we are having the time series or continuous the data, then we have to use this one, that is a regression. You have to analyze whether it is a regression or classification or clustering or like the anomaly detection, or it is an reinforcement learning. Okay, that is one thing, right? So yeah, let me, okay, yeah, just a minute, guys. That is one thing. And yeah, so second is the classification. So if our use case is to do the classification, right? So what we have to do is we have to see the proper model. Okay, that is we have the random forest. So this is also a well-known ML model for the classification, and also we have the light GPM, and we have also have the BERT. Okay, so the it is like categories. If we have the different data sets, right? If you see here, and you want to do the categorization, not the regression. So in that specific use case, we have to select the specific the ML model. Okay, and so let's say we have a different use case where we are trying to do the anomaly detection, right? The clustering. We have to do the clustering. When I say the clustering, if we have the data sets and we need to analyze any specific event or else anomaly, theft detection, right? In the energy management system. So in that scenario, in that the problem, we have to use the different the model. That is the very famous one is the K means machine learning model, and also the isolation forest and autoencoder. So these are all the machine learning models what are famously selected when we wanted to do some anomaly detection or the clustering one. Okay, and the last one is the sequential decision. So let's say we have some the data set. Based on the data set, we have to take some decisions. That is sequential decision, right? For example, we have the IoT device which is sending some sending some data to the server. Okay, so in the step one, we need to take some decision whether the IoT device needs to be turned off or on, right? This is one of the decision. And the second condition would be on what state what state this action needs to be taken. Okay, that will be the second sequential decision. And the third decision, whether we have to continue the on and off status. And so basically what I'm trying to say is, like, whenever we have this sequential decision requirement, right? So we have to consider the reinforcement learning. Okay, for that we have the DQN. So this is very much the famous the machine learning, the models we are having. Okay, so yeah, in the first place, in the first step, we have we have identified the problem statement, right? And also in the exam, if you get any of the question on this specific, right, you have to start with the statement as step one in the defining the problem. Okay, you have to know whether you want a regression or classification or like anomaly detection or reinforcement learning one. Okay, good. So now again, in the starting, I was giving an introduction about the data types, correct? Now let's say in the step number two, deep dive, we have to check the tabular column as structured data. So when we are having the structured data, then yes, we have to use the XG boost light GBM random forest. Okay, that is one thing. And if it is in time series, and you have to know these, okay, the data, okay, the tabular and the structure and the time series. Time series is the continuous data. if our the energy management system or less IoT is sending continuous data, so at an interval of 1 second or 5 seconds, right? So and you have to analyze those data that comes under the time series, and that is like used by LSTM and the profit and the transformer, this one, okay, ML models. And the third important very famous and which is unstructured one is like the text data, okay. In the text data, like if we want to analyze this text data, either two, one is the BRUT and one display. So we'll just focus on this specific ML model, that is BRUT, okay. And the fourth one, if this is like high dimensional sensor stream, okay. And third, the data, it could be in very large data sets, okay. So you have to keep in mind these are all the some of the common data sets available, okay. I mean these are all the datas types we will be having in the energy management system as well as IoT, right? Usually, okay. And coming to the mapping with the constraints. So we, in the step one, we defined the problem statement. In the step two, we got to know that what are the data types we will be having, correct? Now let's understand the constraints. So we might need different requirement, right? So for example, when the deployment speed, so we want an very much faster deployment and faster results, right? So that is one of the constraint, deployment speed, okay. If we have the enough timing, or like we can able to take a little more time, then we can able to use the different ML models. So you need to identify the constraints. Here, the constraint is deployment. When the deployment needs to be very much speed, there are like different ML models, the tiny ML, the TF Lite, the containerized models. So these are all the small models which will be very much easy to deploy on the edge. So in the yesterday's class, I was discussing about in this edge computing, right? Where IoT device by itself will come with an RAM and also the also the storage, correct? And few CPUs. So this is the latest IoT device is capable of running this smaller ML models within the this device also. Or if we have the the servers, the local servers, the small machine, then also we can able to directly deploy these small ML models and run the machine, run the this data set in that machine, okay. So this is one constraint. And the second, coming to the second constraint, now like let's say we want to have more visibility, okay. In that case, let's say if you see here, we have the two, right? One is the black box one or the transparent one. So when we have to have the more visibility in terms of results and data analytics, right? We have to choose like the random forest, like other light GBM, and so on. So these models will help us in giving more transparent visibility in terms of the model results and the model, the training part. Okay. And the third constraint will be in labeled data. Whether the data is labeled or not, like whether we need the the data, we need the result in terms of labeled or like any other the output, right? So in this specific constraint, we have to identify how the data needs to be modeled, right? On based on that, we have to choose the different ML models, right? For this, we have the isolation forest, autoencoder, and the k-means. Okay, and right. So let's deep dive into little more scenario-based one. Okay. In the field guide, let's say initially I was talking about the time series and the demand, correct? So we have the important one, LSTM, okay, and the profit. Let's say just a minute. Okay, so yeah, and now let's understand the when we need to use the time series and the demand. Let's say we have selected the two models, LSTM and the profit. Okay, we will deep dive into these models in the next session. How exactly these models are built technically. Okay, for now you just understand where exactly these models will be fit into. Now this LSTM, that is the heavyweight one. So these are all the very complex models. These are all the best suitable for the energy load forecasting and the sensor time series one. Okay. So when I say this, when so load forecasting is not specific for the one small sector, correct? So we'll be having large amount of the data coming in from the different places, and if you see, you know, uh, the complexity of the load forecasting, which will be very much higher, correct? So what it will be doing is, so why it is best fit for the load forecasting one? Why? Because it captures the long term and temporal and dependencies and multi-variety imports. So this the model is very much good because it takes the multiple imports, multiple formats, and also it will help us in the understanding the complex data sets. So in the in terms of the forecasting and of the time series one, right? That is one thing. Because of that, we have to use this LSTM one. Okay. So coming to the weakness part, right? So weakness part, this having the compulsory expensive need, right? And it needs the larger data sets. So if we are, using smaller data sets, then it will not work because so these are all the models which already trained on the bigger, larger data sets, and it is capable of analyzing the larger data sets, correct? So it always expects us to provide the larger data sets, right? If it is in smaller data sets, it may not be the right model to choose. Okay. And this one, the next one is profit. So this is very much suitable machine learning model for the business partners. Okay. So this is for the energy load forecasting, right? The LSTM, and the this profit is best suitable for the business demand forecasting, not the energy one. Okay. And this is for the demand forecasting and the operational planning. So if we have these specific the field that needs to be addressed, right? So you have to choose the profit ML model. Okay, coming to the strength, right? So you see here, like it is the handle seasonably automatically, it can able to handle it. So when I say this, like uh, let's say we have seasonal data coming in. Okay, for example, in the business always needs the data in terms of the quarterly inputs and quarterly analysis, right? So we don't have to analyze the data in continuous series. In when it comes to the load forecasting, we have to analyze the data every second and every minute, right? But in the business it is not like that. It is a seasonal right? So usually how the decision making will happen is based on the quarterly or like half yearly or like yearly basis, right? For that reason, we have to choose this specific the model, profit model. Okay. And coming to the weakness part, so this model is less accurate. Okay. On the non-seasonal data and also the single series at a time. So This is one of the disadvantages of this the model. So if we are, want to have the higher accuracy, right, on the seasonal data, not on the series data, it is on the seasonal data, then this is not the right model. Okay. And if we have only one, series, the time series, the data coming in, then also it will not be the great model to select with. Okay. That is what. So when it comes to the time series and demand, the two one LSTM and the profit, what we will be selecting. Okay. Now coming to the second one, that is tabular data models, that is ML models. Okay. So we have a two type. So XGBoost and the light GBM. Okay. So coming to this specific XGBoost, right? So this is mostly used in the solar forecasting. Okay. If you see here, solar forecasting, where we are trying to analyze the radiance, right, on the certain period of time. So how the the behavior of the radiance on the specific area, and we are taking the data, and we are putting in the uh, tabular format. Okay. And so how, why it is very much useful, what is coming to the strength, right? It is very much faster in the training. Okay. Handles missing data, excellent feature impotency like regulation and so on. So when I say this, so for in the few of the scenarios, what will happen is whenever we are ingesting a data from any source, correct? Let's say this is an solar PV module data which is sending the details to our server. So sometimes what will happen because of the network issues, so the data may miss out, little the smaller data might miss out in the transit, correct? So this model XGBoost, it is excellent in the handling the missing data. Okay. So how this handles is, so this model is trained in such a way with this similar kind of data set that it will predict what could be the value, even though there is missing value in the the data set which we are ingesting from the raw data source, right? So this is where it will be very much helpful in the solar forecasting. Okay, it is not only the solar forecasting; it can be used in the wind forecasting also, right? This is one thing. Now let's see. Coming to the disadvantage, the weakness of this is, so again it can fit a smaller data set, but it is overfit for the small data set. Okay, if we are having the small data set, again it is not suitable one. Okay, because the model is suitable for the very larger the tabular column set. Okay. So it is not fit for the smaller data set and requires engineering for the time series. So it is little more complex when it comes to the time series one. Okay. If we are continuously ingesting and try to analyze, this may not be the right fit. So in that case, we have to go for an LSTM. So this is the time series one, right? LSTM and the profit. Either one, we have to choose it. So when we have the data which is stored in the columnar, like as in bigger data sets, right? We have to choose this XGBoost. Okay. Coming to the other one, the light GBM. So this is like one of the the models which is best suitable for churn prediction. Okay, and the customer analytics and the large scalar tabular data. Okay, so let's say you have to do some customer analytics. Okay, for example, let's take an example like I I am running an energy, the company where I want to see how the customer is utilizing or else customer demand is, right? So in that scenario, like for the customer analytics, this is the best ML model, that is light GBM. It is good, extremmely fast, and memory efficient. So these are all the two key features what makes this the light GBM very much fast, because it is very much memory efficient and natively categorically supports the model. Okay, that is one thing. And coming to the disadvantage part, right? So again, the smaller data set, it is the worth and yeah, it is less interpredictable without SHAP. Okay, you just think like this is not fit for the smaller data sets. Okay, again. And coming to the third part, that is, if we are planning for any anomaly detectors, correct? The best model is the isolation forest. Okay, why we have to choose this? So it is a faster the model which filter out the actual data, and it will detect the fraud detection. So as it is saying, right, the best suitable for the energy theft detection. It is not only the energy theft, if we are like having any of the software related to the transaction also, right? So in that case, if you want to find out any the fraud happening in the network, or else like any breaches is happening inside the network, right, we can able to use this specific model for the detection of this. How it will be doing is, so this is an unsupervised, the fast scales well, and we don't need to have any labels for this, right? It can able to detect automatically. That is one thing. Coming to the coming to this downside of this is, one second. Okay, so coming to the downside of this specific the model is, so it struggles within clustered anomalies. Now let's say for example, if the data the anomalies are in the clustered format. So if there is an, for example, if this is a complete cluster of anomalies, right? So in that case, it might struggle. Okay, that is one of the biggest drawbacks what we are having when it comes to the this specific ML model. Okay, and the other one, that is the auto encoder. Okay, in the auto encoder, this is a very much best suitable for the IoT multi-sensor anomaly detection. Okay, network device monitoring, if we have the use case where we have the multiple IoT sensor anomaly detection required, or network device monitoring is required, in that specific, in your syllabus, right, it is focused mainly on the IoT, right, IoT and the cloud integration. In that case, we need to use this auto encoders. Okay, and so this is mostly for the IoT multi-sensor anomaly detection. And why the coming to the good part about this is, that is advantage, is like learns the complex correlations. Okay, if you see this the point, the learns the complex correlations, right? So that means if we have the multiple IoT devices, right? Just a minute, guys. Okay. Yeah. So what I was explaining. Okay, so learning the complex, the correlation. For example, so I have a multiple kind of IoT devices, right? So in that, so there will be a very complex these IoT devices talking to other IoT devices, and it is sending these two are sending the datas, exchanging the datas. Okay, and if you consider the other IoT devices, these IoT devices might be exchanging different kind of data. So basically, these two are talking different, sending and receiving the different data, right? It different parameters. I mean, like these two IoT might be sharing the different the parameters. So this model, the autoencoder model, is the good in such a way that it is it can able to correlate the complex uh, interconnected data sets. Okay, and this also works without the labels. Okay, we don't have to have the data sets with the label. Without the unlabeled data set also we can able to analyze, and it is flexible one. Okay, so coming to the disadvantage part of this autoencoder machine learning model, it requires the careful threshold selection. So sometimes what will happen is if you are not selecting any threshold for this machine learning model, right, it may not be giving the proper results. So we may get so different kind of result which may not be accurate one, right? So we have to be very much careful in terms of the threshold selection, and it is very much harder to interpret. Okay, when I say it is harder to interpret, whatever the data output we are getting from this model, correct, if you want to go inside the output of this specific model, and if you want to do some analytics based on the output we got it from this machine learning model, right, so it will be very much difficult for us to analyze this. Okay, this is one thing. So yeah, coming to the third part, the field guide, the specialist one. Okay, in this specialist one, we have the random forest. So this is very much a famous machine learning model. Okay, you might have heard about this machine learning, right? The random forest machine learning. So this is one of the important model. In our case, what we are going to implement is that is for the predictive maintenance and the industrial fault classification. Okay, why this model is very much suitable for this predictive maintenance and industrial fault classification, right? So it is a robust, interpredictable, and the feature, and it handles the imbalance classes. Okay, let's say we have the transformer or as like a building management systems, the complete infrastructure, right? So sometimes there will be an imbalance in the classes. So it is very much uh, the model can able to handle these kind of variables, right? So that because of that reason, so this is one of the best suitable model for the predictive maintenance. Okay, coming to the weakness part, so this model is slower, okay, than the light GBM, the one which we saw earlier, right? And this is slower when it comes to the larger in the data set. So here the data's the classification of data, we call it as in forest. Okay, so when it comes to the larger forest, so this specific model will struggle. Okay, we have to be very much careful whenever we choosing a model, right? And also it is an memory intensive one, so it requires a lot of memory. When I say the memory intensive, so whenever we want to run this machine learning model, right, in the system, so we need to have large amount of RAM, large amount of storages, and also the CPU. So this requires extensive resources, right? This is one thing. Okay, next comes to the best. That one is like BERT. Okay, so this is neural NLP, neural network based machine learning one. Okay, for example, if we want to do some analytics based on the customer feedbacks or the document classification. So it will be extremely well connected document, extremely complex document, which has the connectivity to different data sets. So whenever we want to analyze these kind of data sets, okay. So for example, we have a different data sets, customer feedbacks, and the machine output, and the sales, and energy forecast. So these are all the different data sets serve for a different purpose. So when you want to get or like establish the connection between all these data sets, right? So it is very much pretty much complex analytics. What we are trying to do is, right, in this is the best the suitable model which learns on the neural networks, right? So this is the model, okay, which is best suitable for the state of the art text understanding, okay, transfer learning, bidirectional context, and so on. And coming to the disadvantage part, right, on this specific model, it is very much larger model. Okay, you see, it is not only the CPU required, we need the GPU also. So the initial investment on these the models will be very much higher, and it to train these models required a lot of time and resources. It is pretty much costlier model, right? That is the disadvantage of these models. Okay, so let's continue. So, okay, great. Yeah, so let's understand, in a broader view. So, what exactly the trade-off, right? So now you see this graph is to understand which model fits in which category. Okay. So initially I was talking about LSTM and the breadth and autoencoder, right? So if you see here, this is the slower one. Okay. Slower and the heavy, right? And so whenever like you are choosing any specific ML model, right? So these are all like the heavier, but it has these are all the models which is suitable for the larger data sets. Okay. And coming to the faster one, so faster one we have the isolation forest and light BGM one. Okay. So interpredictability, so when it if you see this part is interpredictability, and this is like the speed one, right? Interpredictability for this specific the models are little lesser. Okay. And when you want the best model, you see here the transparent and the faster at the real time, the only two models which stands out is the random forest, right? The random forest and the puppet. So these two are like little good models, so which has the good the speed and also the good output when it comes to the proper analytics one. And XG boost also it's a pretty much good, but so yes, this is the trade-off, and you have to know these little differences, okay, to understand what exactly the machine learning models are. Okay, that is one thing. Yeah, so these are all the very important, the concept now. So uh, we are trying to match the models to the hardware reality. Okay. So see, we were discussing about one of the model, right? The tiny ML. So it is extremely constrained, then require continuous model. Okay. So what it means is like fine. So this can able to run on a smaller machine, smaller thing. Okay. And that is one thing. And it may not require much resources compared to the other one. Okay. That is why we are telling that it is extremely constrained one. Now, coming to the other models, right? So you see, I was mentioning earlier also. So this required heavy CPU utilization. That is, resource required for this is very much higher. Okay, and the good part about is, see here, it is extremely low latency. That is less than 10 millisecond is what we are getting out of this. Okay, and coming to the models, it requires heavy infrastructure. Okay, especially we need to procure the higher GPU for to run these models. That is bread, LSTM, and the complex encoder. Okay. Now, just to summarize and conclude this section, so this is very high level, right? The matrices. So what, how many models we, got introduced to? That is totally 10 models, right? 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 8 models. Okay. And the first model, that is LSTM, that is for the regression, best suitable for the sensor and the time series data sets. Okay. This, when it comes to the speed, it is slow, but heavily, heavy computational one. Because of that reason, it is slow. And so it is like the black boxed one, and it is primary use case is load forecasting. Okay. And the second one is XGBoost, that is the regression and the classification, and the ideal for the tabular format data set. The speed is the mid one, not that good or that bad. It is fair enough. Okay. Interpredictability is very much higher. Okay. In this, LSTM is lesser compared to the this specific XG board, and this the model is well suitable for the solar forecasting one. Okay. And the third one is isolation forest. So that is specifically required for the anomaly one. Okay. And again, this is also for the time series one, and it is faster, and interpredictability is mid, not that great or not that less also. Okay. And this is specifically used for the energy theft and the fraud. And coming to the other one, the random forest, right? That is required when we have the classification problem. Okay, we need to solve the classification one, right? In that case, and ideal for the tabular column, and it is for the real time and higher predictive maintenance is where the primary use case is. And other one is the autoencoder. Again, this is we can able to use for the anomaly time series data, suitable for time series, but this can able to handle the heavy data, and because of that, so even to handle this heavy data, we need they need little time, right? So for that reason, it is little slower compared to the other models. And interpredictability is like the black box one. It's okay, not that great. And especially when it comes to the primary use cases, it is for the IoT multi-sensor one, right? And the other one is light BGM. That is again, if we have any classification problem, right, we can able to use it. And the data set is for the tabular data set, the faster. And interpredictability, it is low, but it should be okay. And the primary use case is churn prediction. So how many customers are like leaving the service, or like how many customers are like utilizing the energy, and so on. So that kind of the primary use cases, if we are having, then we can able to use this specific like GBM. Other one is the profit. Again, the regression, the time series, and the speed is mid, not that great. And interpredictability is very much higher. So this can be utilized in demand forecasting. Okay. And the breadth for the classification again. And this is ideal for the, the text formats or any kind of other formats, and required very much higher GPU. So interpredictability is the black box one, that not that great. And this uses NLP analytics, where our the primary use case to analyze the complex data set, right? So that is where it is used. Okay, this is the introduction to your ML model, specifically focused towards the energy and the IoT systems. Okay, now let's go a little deeper in each model. Okay, so before I go further, like if anybody has any questions, let me know. Okay, let's go to the machine learning. Okay. Yeah, so let us start with the analytics one. Just a minute, guys. Let's start with an analytical ML. So to start with, I will be showing one document. That is for the K-means. Okay, yeah. Great, let me share my screen again. Okay, here we go. Hmm, model deep dive. Okay, it should be fine now. Okay, let's start with the K-means, right? So as I was mentioning earlier, right? So I have divided this session, ML session, into three parts, right? One is for the machine learning for analytics, ML models for analytics, and the second one is ML for the energy, the management, and third for the IoT. Okay, so as the analytics is very much important for us, right? So let's start with the analytics one. Okay, the first ML model, that is the K-means clustering for the uh, it could be used for segmentation of the customers. Okay, it is not only for the customer, we can able to apply this for the IoT or building management devices, right? That is one thing. Okay, let me, yeah, so this we already covered in the last PPT. Okay, so this again, just to give you a highlight, so if we are trying to categorize the customer, who are our customer, the tool is like the K-means clustering, and what will be our sales for tomorrow. In that series, the profit is the machine learning model, and what does customer feedback means. Like if we are trying to analyze that, then the bread is the the better the model, and what customer are about are which customer are about to leave us like this kind of analytics, then the light GBM is the better tool. Okay, so let's say you are planning to create your own the paper in terms of energy management, or like the customer who is consuming the energy, right? So if you are trying to create some paper out of this, so you just keep this in mind, ML model, which ML model needs to be chosen for the which category. Okay, this will help you guys out. So apologies, guys. Today, my system is not at all supporting. It is continuously restarting. I don't know why. So sorry for that. It's been like too many interruptions, right? Okay, no issues. So let's continue further. So I was talking about you know the specific model, that is the k-means one, right? So let's understand what exactly this is. So this is one of the model which is specifically for the analytics one. Okay, so how the things works. So this is focused towards the business goal is towards the customer segmentation. Let's assume this. Okay, the just to take an example for our understanding, I have taken one example, that is we have 1,000 number of customers with a diverse behavior. Okay, obviously because all the customers are the not same, right? So they will be having different the opinions, different type of selections, and different type of feedbacks, and those kind of different categories, right? So you see this map, correct? So before, like, it was scattered. Okay, and when you have these kind of scattered and different vertical the customer and their feedback data sets, right? It will be very much harder for us to analyze those data. So what we will be doing is, if you see this specific the model, ML model, right? So it is trying to categorize it. Okay, so see here. So K means clustering and unsupervised machine learning, which we already know. What it will be doing is, so it will automatically organize the raw data into the distinct group. Okay, this distinct group is called as the cluster. So the K means the machine learning algorithm, what it is trying to do is, it is clubbing all the related data, okay, into the single cluster. And let's say here in this specific use case, we are trying to cluster the customers. Okay, the similar customers. It may not be an exactly similar customers, but it could be in similar for at least for in threshold level. Okay, and so once we have done this, it will be very much easier for us to do the analytics. Correct? When we do this kind of categorization, right? So here, main core objective is to keep the data points within the each group as tight and as close as possible. Okay, this is the objective of this k-means. Now let's see how the k-means works by step. Now first, what the k-means will be doing is, let me open the pen. Yeah, just a minute. Okay, this is, yes. First, initially, the K means the how algorithm work is. So it will identify the star center. Okay. So the model randomly picks the K. K is that nothing but any one of the the data point it will pick. Here, let's take an example of the customer, right? It will pick any of one of the customer, the data, and it will start pulling the other data set towards it. Okay, the similar data sets. Okay, central, it is called an initialization. In the start, it will pick a random the k value, which will be an like an centroid. Okay, and then it will start pulling the data which is equals to that data, or it might be an relevant to that data. Okay, once this is happening, in the second stage, that is assigning, every customer is assigned to their closest center point. That is what I was taking, right? Once the in the initial stage, the model will select specific data point, and then the data point will act as a centroid, or we can also call it as a reference point, correct? Once we have defined the reference point, what the k-means value will work is, it will assign other data, nearest data to the this centroid. Okay. Now this is the second step, that is the assignment. In the third one, it is recalculating. So we are trying to recalibrate, because in the second step, it is not the exactly we are trying to cluster the data, correct? So when we, in the third stage, it is all about the calculating, right? When we see like, okay, these are the data, this is fine enough, but we can able to reshuffle it, right? So that is what in the step number 3 it will be doing is, the center point moves to the true mathematical middle mean. Okay. So now again the data will be moved, or else like the center point will be moved, so that once everything is done, it is a continuous iteration of the step. It is not the one time objective and it is done. No, these steps, the initialization and the assignment, recalculation, and the repeating, so it will be repeating continuously after certain point. So it will say, okay, this is almost near to what exactly we are looking for. This is nearly the clustering. This efficient clustering is what we have done it. So once it is done, then it will give the result back to us. Okay, that is what the k-means is. Now in that there is one specific the elbow two methods. One is like elbow method. Okay. So how are we going to say whatever the results or whatever the clustering it has been done, the model has been done, whether it is good enough for us or not? How do we do that? So there is two methods. One is elbow method and Celoste score. Okay. Now, what exactly the elbow method is? So in the elbow method, what we will be doing is we try different number of groups, right? So we'll pick any one of the group for first testing, and we look for an elbow on a cart where adding more groups stop significantly shrinking the distance between the data points. Okay, what it means is, so this is the optimal k value. Okay, there will be a predefined the measurements. So whenever we pick a group starting, that is what it is telling, we have to check for the reference point. If this specific point and the group, it is not matching, or else it is like it is in this part of the line, then it means like it is not that great. So it has to be converging, right? So that is how the elbow method is. So we are taking one reference point and checking all the groups where exactly the group is laying. Okay, if it is at an higher side, then we say, okay, this the whatever the output we have got from the model, it is not that great. Okay, that is how it is. Or else we can also use the scoring model. Okay, scoring model starts from the -1 to the +1, right? So if it comes to the 0, then it is neutral. Okay, the grading, how it works is the measuring coins, like see, are the customers within a single group very similar or close to each other? So this is what it is trying to measure. And if it is near to +1, then whatever the categorization what we have done is proper. If it is like near to the 0, okay, the still the categorization what we have done it is okay. But if it crosses below certain the value, that is below the 0 or negative 0.8 or something, then we say this categorization whatever the model has been given to us is not that great. We have to do the reiterations. Okay. And that is what the first step is, whether the group whatever the model has given is proper or not. Then again we will be checking the accuracy of that. Okay, and these are all the two methods. One is we are taking the help of the graph to identify, and the second one is we are taking the score, which will be in a -1 to +1. Okay, that is one. So this is how the model is. This is just a brief introduction only, and there is way complicated, the paper on this. Like I will be providing the link, and for your examination, you don't have to worry about any technical part. Okay, so try to understand how many ML models are there, like when to choose on your energy management system, right? So these are all just an introduction, and you don't have to worry about this technical part. Okay, but yes, if you are implementing these in your assignment, then you have to go a little bit deeper on these machine learning models. Okay, and also you have to write little bit of the code. So coming to the code part, so I have given one example code. Let me show you. uh, okay, so I was able to get one little code here. Okay, so this is the code. And yes, again, I'm reiterating, if you are planning to create any of the machine learning in your assignments, right, you have to write in the code. So these code needs to be run in the any of the platform. So here in our lab, we will be using the AWS, right? In the AWS, we will be using the SageMaker. Okay, in the SageMaker is the the better place to deploy these smaller models which we will be creating, and there we will be train the model, and then we will deploy that model to test the system. That is one thing. So here this is just in sample the code what I have generated here, what it is telling. So what I will be doing, this is one of the code. I will go in the little depth because most of the you guys may not be knowing complete details about the packages, right? So I will take little more time here, so that in the future, if you want to create these kind of models, right, it will help you guys a lot, right? So now coming to this specific example here, what I am trying to do is, so a scenario, a utility company segments its customer base on the energy consumption pattern. Okay, to design the target demand response and the price strategy. So we need to develop one ML model. So basically, we as a company, we are trying to analyze the demand response. Okay, and also based on the demand response, we are trying to vary the price. Okay, the more the demand and the pricing should be automatically vary based on the real time. That is what the system is. Okay, that is one thing. Now, so most of the ML models are written in the Python language. Okay, so why especially on the Python? Because the Python has an the large number of libraries. You don't have to start with a scratch. So you just have to know which the packages needs to be imported in your coding. Okay, in this specific code, what initially what we have to do is, whenever you start any the Python coding, right, you have to import certain libraries. So the first command we need to give is like import, and these are all the packages: NumPy, Pandas, and the sklearn clusters, the k-means. The k-means is the algorithm what I was mentioning, right? So this is the specific package. What it will be doing is, it will pull the the details like elbow references or else scorecards. So these kind of references it will pull from this library, so that you don't have to write the code from the scratch. It is already pre-built. You are trying to import it. Okay, so this is the pandas and sklearn. So this sklearn is one of the library which is extensively used for the machine learning the packages. Okay, from this specific term is saying that I want to import this k-means from sklearn cluster. And in the similar way, I am trying to import the other packages which is relevant for me. Okay. These are all the packages. And this specific package, if you see MATLAB libwrite.py plot, this is used for to plot the graph in the pictorial representation for the visualization. Okay. This is the famous, the packages which is available, the plotlib. Okay. And the Seaborn. Also, these are all the packages which is necessary to build the model, ML model, and the train the model. Okay. Now let's see. Now we'll define the load of the customer data. Okay. Energy. Let's load the customer energy data. Let's say we are defining it. We are trying to read the CSV file. Here the format is the CSV. For then the easier understanding, what we are trying to do is we are trying to read the CSV file. The CSV file name is customer energy profile dot CSV. You might be having the different the file name, correct? If we are in the real time, if we are fetching the data, it could be in different format. Okay, this is one thing. So I'm trying to read the file, and then what I'm trying to do is I'm trying to feature the customer profiles. Okay, we are trying to see what exactly the profile of the customer are like. How are we doing is we are trying to let's say we are looking inside this CSV file and telling, okay, what exactly the average daily consumption we are taking, and we want to see the annual kilowatt and the peak to average ratio and the peak to demand and the completely annual kilowatt hour, right? That is one thing. And also I want to see daily activity also, right? So the morning share, like I want to see the morning kilowatt hour, the evening, the weekend, the summer, and the average demand, the peak demand, the winter. And if they have the solar generation, then I just also wants to know what exactly the solar kilowatt exported from their facility or like their home. Okay, and if they have the EV charging, and what is the output of that EV. So these are all the important parameters what I want from the customer, right? So to have the demand. So this is the the field which will be inside the CSV file, which I have already gathered from the customer. Okay. Now, once we have this data, so these are all the labels. You can call these as an labels. These data will be stored as an columnar later. Okay. Now think this as in just a label. Okay. This label will be saved in the CSV file, not the other columnar format for now. Okay. For the analytic purpose in the future, these has to be converted into columnar format. That is the ORC or else PACQ2, the format. Okay. Now let's do some cleaning of the data. Okay. What I am trying to do is, so I am trying to normalize the data. Okay. I am trying to use the libraries. Okay. And I'm trying to fit. This is the one of the transformation library code. Okay. So when you see here, the scalar dot. So what I'm trying to do is I'm trying to pull this library, and from that library, we are trying to do take some action, right? On the features. What is the features? This is the feature. Okay. The feature will be having these data, and these data I'm trying to do the transformation. Okay. That will go to the X axis. Okay. Now, let's do some, the K means elbow method. Here, we are trying to do the both elbow method as well as the scoring method. Okay. Now, so here we are using the for loop. Okay. And also the K means this is where we are trying to pull in the library, where the library will be, having this K means algorithm. Okay. So algorithm needs certain inputs. Okay. The clusters. the random state. So this is the random state where we have to give some value. Okay. And this is the k-means and the labels. So label where it comes. So it is coming from the this earlier data. Okay. And then what we are trying to do is we are trying to create one reference points. Okay. In by using the libraries, right? Here again. So we are trying to select the optimal k value. For example, here k phi based on the elbow, and you this is like understand like this. We are trying to give a reference point. From the reference point, if the value is the after this reference point, the output we are assuming it's good. If the value is the below that specific point, then we will say the output is not that great. Okay, this is where the reference point comes into the picture. Okay, now we are trying to analyze the cluster. Okay, so we are trying to pull the cluster profiles. See here the features. Feature is again the CSV file. We are trying to group by cluster, and this is the function what we are calling the means. Okay. So basically, in this specific, the function, we are trying to do the analytics. We are trying to do the, not exactly the analytics, but we are trying to do the clustering part. Okay. Once this is done, we are trying to print the output, and so now the output will give the results. Okay. So these are all the characteristics. So zero means low usage apartment, the high industrial, usage, the solar, the prosumers, that is the customer is can able to pump back the power to the grid, or like can able to consume back from the grid, both the ways, right? The bidirectional ways. And EV charging, the household, the peak intensive commercial. So based on these tags, we will be categorizing, right? So this will come from the algorithm which we have set in this specific section. Okay. Now again, so we are again pulling that and the feature set, and we are trying to map that to the specific segmentation. Now this in this specific section, what we are trying to do is we are trying to categorize the data from the CSV files. Okay, once this data is been CSV file is pulled and it has been clustered, okay, then we have to do the insights. Now what I'm trying to do is I'm trying to get the that the cluster into my visualization dashboard. Here I am just pulling the different data set into my visualization dashboard. Okay. So yeah, so again in the last section, it is always it is all about the recommendation. Okay. This is telling if the customer cluster ID is 1, then it is the demand response is intensive. If the customer cluster ID is 2, is the net metering optimization. If the cluster ID is 3, then it is off-peak EV charging intensive, right? So 3 clusters what I have built: cluster 1, cluster 2, and cluster 3. And these 3 serves the different purpose, right? So this is how the small programming will work. So basically, just to summarize, we are trying to import some CSV file. Then by the library, k-means library, I am taking, I'm feeding this CSV file to the k-means cluster, and the cluster will automatically categorize the data which is present in the CSV file. And 3 different clusters I am preparing, and based on the score, I will be getting what kind of customer they are. Okay. This is very much high level, and this is little complicated. You may take little time. Okay. This is just to introduce you guys to the how the programming works, and we can able to do the ML modeling. Okay, so this will we will try it out in the AWS console in the machine learning, and again while doing that, I will again explain this specific model. Okay, there it will be a little smaller model compared to this because explaining this in step will take some time. Okay, for that reason. And that is the K means one. And let's go to the profit, the second ML model. Okay, we'll do one thing. We'll take a little small break now. Okay, before we jump into the this second ML model. Okay, let's take one 15 minutes breakfast, and we'll come back exactly at 9:17 or 9:20. Okay, bye. Okay, let's wait for another 1 or 2 minutes. Okay, then we'll start and we'll complete this the models for the analytics. Okay. Okay, let's start and we'll finish this part. Okay. Yeah. So the second model for the analytics is the profit. And the good part about this is this was developed by the Facebook, right? Now it is called as Meta, and this is in the time series library. When I say the time series, it means like 1 second. Yeah. So it means like the continuous data at the real time we can able to do the analytics. Okay, this is the time series. The data needs to have the timestamp whenever we ingest the data into the system. Okay, so the problem statement. So the predicting feature, it will be very much difficult if the data is fluctuating daily, right? If the data is very much fluctuating daily or weekly or like the yearly, then actual the prediction, the accuracy of the prediction will goes in the sideways, right? Though that could be because of some holiday season or else like because of like off season, that kind of the gaps what we will be having in the data set. Because of that, we may not be having the proper prediction. For that reason, what this model will be doing is, so this model will help us in the breaking down the historical. 1 second. Yeah. Breaking down the historical time data. Okay. And then we are trying to predict the future. Okay. Basically what we are what this specific ML model will be doing is, so it will handle the messy business data, and also it will handle the missing information gracefully. Okay, let's see how it will be doing it. Now see. So this specific model, ML model, the profit, so that breaks our data into the smaller the building blocks. So if this is our time stream data, so let's say this is the data at over a period of 1 year. Okay, the day one, the day 1 to day 365. Okay, now let's say these the data will be divided into different the blocks. Okay, for the analytical purpose only, right? So now what is what will happen if we are breaking this into the smaller blocks. So each blocks can easily can be able to analyzed, okay, by using the model, and specifically we can able to get the insight in that specific block only for a calculation purpose, right? Let's say we have the seasonal, okay. For example, we have the longer the holidays. In that duration, probably the usage of electricity might go down or might go up, right? And that is an unusual behavior, so that is not the normal one. Or else, like during the night, suddenly there is a sudden peak in the industrial demand, okay, on only that specific duration of time. Okay, so these kind of the surges, everything will come in the certain the blocks. Okay, when you divide these blocks, we can easily can able to identify what could be the trend. Okay, so that is how it is. This specific the model will be doing it. See, if you see here, there is like unusual behavior or like the spike in the demand. Okay, so these kind of trend what we can able to set, and you see we can able to do the final forecast what can be the uh, you know uh, the final the output will be, and we can easily say what will be the energy consumption. Or else it is not only the energy consumption, the utilization of other resources, how it will be in the coming future. And it is not only the forecast, we can able to do the same thing with the historical data also. We can able to see what was the specific the demand at specific time. So this is one of the good part about the profit the ML model. Okay, the so why this is so much famous? So the business team, why they are relying on this the profit one. So they handles the missing data, okay, without the breaking the model. Okay, as I was mentioning earlier, right? So because of the various reasons, the data may not be contain the relevant data sometimes, because due to some of the network issues, or like some error or corrupted files, and it could be in various reasons, right? And the data might be inconsistent, or else some data might be missing in that data sheet. So this specific model is smart enough to identify that and fill the gap. Okay, that usually can able to fill like an average value or like a random value and so on. There are different techniques to fill those missing data, but we'll not go into depth on that. But think like this specific model can able to handle the missing data gracefully. Okay. And now the second part is adaptable. So it features then automatic change point detection to instantaneously spot when the underlying business trend shifts. Okay, this is the key part. So it is adaptable, even though the business is running on a specific the trend. Okay, it can able to analyze the change in the trend. Okay, for example, for let's take an example of energy consumption, right? So certain group of customer are using the energy in a certain way. It could be a medium usage, okay, and slowly the consumer, the same consumer is utilizing the very higher energy, right? So this shift in the change from the lower energy consumption to the higher energy consumption, right? So over the time duration, the model will understand the usage pattern, and it will tell, okay, the consumers are slowly moving towards the higher the consumption of the energy. So based on that, we can able to increase the energy the production also. So this is what the adaptability comes into the picture, right? It will detect the change in the trend. Okay, and the third point is interpredictable. So you can isolate and look at the trend or the seasonality independently, okay, to understand the underlying drivers. So predictability is like we can able to zoom into the specific duration, and you can able to see at the specific interval of time. For example, let's say we want to see what is the energy consumption during the month of holiday season, that is Diwali. Okay, just to take an example. Okay, so based on the historical data, we can able to go in the depth. Okay, and even the model can able to do the same thing without the human intervention. It can able to go in the depth and see what exactly that the readings of that specific month, what is the consumption, and it will give the actual confident score, and it will tell, okay, this is what we are expecting this year also based on the last year prediction. Okay, so this is why the this profit is very much the famous in the business analytics. Okay, and I also have the small code for this. Let me share you the code. Okay, let me stop sharing this, and okay, this is the code. Let me share my screen. Yeah, again, so as I was giving an example, right? So this is again written in the Python code, and we just have to import the required libraries. Again, we don't have to write everything from the scratch. So the MATLAB lib and this specific model, it is already written and available in the libraries. Okay, so we just have to import that model. Here I'm trying to import this profit model, and earlier it was the k-means, right? So depending upon what model we need to run, so we just have to import that. And again, here, so required columns we are defining. Okay, the date, daily orders, and so on. So this is like based on our requirement, we can able to change it. So before that, we have to load the data, right? So here we are loading the data in CSV format. Okay, from the CSV format, we are filtering out the required the details, right? Now, we are defining the custom holidays for the major sales event. Here, just an example of the sales event. It could be an energy consumption also, right? So if we are wanted to analyze the energy consumption on the holiday season or like off season, right? You can able to just change the tags here. Here I have given as an holiday like Black Friday, the Cyber Monday, and Christmas, New Year. So this is where I wanted to define. These are all the off seasons. Okay, and in the similar fashion, if we are like implementing this for the energy consumption, right? We can able to give as in the Diwali or like the Christmas and the New Year, where the energy consumption will be varying, right? The demand will be very much higher. That is one thing, and I am defining the upper window and the lower window for the the scores. And in this specific the code snippet, we are trying to build the model. Okay, so yeah, so here I am trying to seasonal model the change points, everything, right? Okay, and then fit the model. Okay, and in the last point, I'm trying to generate the results. Okay, so this code I will share with you guys. Okay, whenever you have the time, you just try to run it locally in your machine. Try to install the VS code in your local machine, and you can directly copy paste this in your VS code and try to analyze. Okay, whenever you are copy pasting this, right, before running it, you just open the datasheet. For example, you just try to learn what exactly the pandas are, like what is numpy, and here the MATLAB lib, right? So what exactly these libraries. Once you understand that, only whenever you call that inside your this code, you will understand what exactly they are doing it. And also you are like this is just a simple code snippet where we are trying to import the library and feeding the data, and everything will be given output. Okay, but so if you're really interested, you have to go into the algorithm, that is profit algorithm, and try to study it. Okay, and in this code snippet, yes, only the simple way I am trying to import the CSV file. I am giving the tags and I am getting the output and I'm just printing it. Okay, that's it. So I will be sharing this code snippet. If you have any of the doubts on this code snippet, let me know once you are trying it so I can help you guys out. Okay, this is all about the model, the profit. Now let's move to the other model, the third model, that is bread. Okay, let me share this. Yeah. So other model is the bread. Okay, and this is most extensively used in the customer feedback analytics. Okay, let's say for our use case, it is all about the energy consumption. Correct. The so if we have the use case to know how the the customer feedback about the energy quality and whether the customer is happy with the service, what the power the provider is providing to the customer, and so on. So those kind of energy analytics, energy the feedback from the customer, you want to analyze those kind of sentiment analytics, right? We have to use this the bread. Okay, what exactly this will be doing is, so here again, I am just taking one example, the problem. So we have thousands of the text reviewer and you know, so yeah, there is the complex human context behind the words. Okay, so basically the customer is providing the feedback. Okay, telling that certain the service energy service is not as per the expectation at the certain duration of time, the power is not great, the power fluctuation, and so on. So they will be giving some feedback in the normal text. Okay, the human words, natural language. Okay, so how do we do the analytics on this natural language, right? So for that reason, what we will be doing is we will be using the bread. What it will be doing is, it is an pre-trained language model. Okay, that reads the massive amount of the text exactly like in humans. Okay, whenever like we get the feedback, the text will be fed to this specific model, AI model, and this is the smart enough. This model is already been trained to read like in humans, right? Once it understand what exactly the text is, it will give the certain the categories. Okay, so it could be a positive sentiment, the product, the feedback, customer service, and the urgent. So it will try to categorize this on a different tags. Okay, now, so how the bread understand the human context? Because humans will be, every human will have their own way of expressing or own way of giving the feedback in their own words, right? How the bread will understand. So the bread, it is a two-way reading model. Okay, so it will start reading from the start of the text, and also again it will come back. So this is what the bidirectional is. Okay, so it will understand the sentiment within that text context. Okay, so yeah, so older model, it starts to read from the left to right. Okay, the bread, it will read from the both side, from because it's a machine, right? It can able to read from the both the side, and it will analyze what exactly, and then the self attention mechanism. So it will maps out heavily the single words. For example, the good. So these are all the good, bad, and there is specific words which commonly the humans will use whenever they give the feedback, correct? Like it was good, it was bad, it needs improvement, and the service, and so on. So those are the key words which the humans will be utilizing whenever we give the feedback, correct? So this specific the broad focus on those words, and it will try to correlate that with the other words within the sentences. Once uh, this is done, so those reference words will be referenced back into the broad, the pre-trained. Uh, we call it as in, like, reference points, right? So whenever the broad links that the words with its own trained references, it can able to categorize it whether the feedback is good or feedback is bad. So those kind of details it will be providing us. Okay, that is one thing. Again, I have written the small code to just to let me show you that. Okay, again, I will be sharing this model with you.